So this next approach that I'm going to show you is a bit more complicated. There's a few more steps involved, but it can also give you a bit more information in some ways and can just allow you to take a different, perhaps slightly more nuanced approach. So what we're going to do is first, we're going to convert this classified layer into a vector data set, right? So what we're going to do is we're going to get little distinct polygons for the water/urban, medium density residential, and then the green vegetation. Right? Now you do not want to convert this layer to a vector layer because you'll end up converting every single little pixel, right, to its own little shape. It's going to take forever. Do not use this one as the input for this. You want to do it under this reclass bin, right? Because what it's going to do is it's going to group any contiguous area of, say, dark red or light green or this purplish color. It's going to group every single contiguous block into its own polygon. So we'll search for the raster to polygon tool. Right? And you want to select it. And then for the input raster, again, this is important. Make sure you use the reclassified, not the raw data, right? And then you see this drop down, either object ID or value. Make sure you go with value. Now we can either simplify the polygons or not simplify the polygons. If you're unsure what an option does, you can always just click this little info button in Arc. And so basically, if it simplifies the polygons, it's going to kind of smooth out the edges to try and make it look better. And if it's unchecked, then it's going to leave the data as it originally is from the master data. Right? So we can first look at what it does when you run it when it's unchecked. Right? You get these exact sort of pixelated looking boundaries, but I don't want you to run it like that. Let's look what happens when you do check it, which is sort of the default behavior on Arc's part to sort of simplify things, right? So look at the differences, right? So it kind of gives its best guess, if you will, as to where these boundaries would be, right? So you can explore seeing what happens with simplified versus not simplified. Now I will kind of give another overview of this in lab, or not in lab, in lecture another time. But if you want, kind of toggle back and forth between the simplified and the non-simplified in the video if you want to get a better idea of what's going on. But anyway, for you to actually run it, make sure that simplified polygons is checked, right? So we just want to give it a slightly simpler look. So what we've done, and we can go ahead and look at the symbology here to see what we did, right? And we can also open the attribute table because now this is a vector layer, right? So we've given it this grid code value of either 2, 1, or 3. 3 is going to correspond to the green vegetation, 2 for the medium density, and 1 for the water. If you want to symbolize it to just see, right? Symbology. You don't need to go with graduated colors. You can go with unique values because there's only 3. Select grid code. Just delete that one. This all other values thing always pops up, but it just looks ugly on the legend. It's my general practice to just remove it if I don't need it. But so you can see here what this looks like. You can kind of compare it to the underlying original data. More or less lines up, but you can see the impact of that simplification procedure here, right? Like look at this little rectangle, kind of converts it to this little triangle, right? So you can kind of get a sense for what Arc's doing with this, right? So now we've got this sort of simplified polygon layer. And I'm going to drag this band CMA over top of it just so you can see, right? We are going to do another process. right? So this layer here now has the grid code, and it could give you the area of any given, right? So this is medium density, forest, urban, whatever. But it doesn't have any of the census information that we also, right? So this stuff, the census data, the CMA, we want to know, how does the income or the housing or the population match up to the proportion of uh, forest area, for instance, right? So we can run another tool. We're going to do something called an intersect. And so again, I'll give a more in-depth overview of a whole bunch of different spatial analysis methods in Module 5. But intersect is one of the sort of more useful tools that we use a lot. So if you just type in intersect, it'll come up here. And basically, it's going to sort of stamp this layer on top of this layer, right? This one on top of this layer, kind of mush them together and kind of combine them and merge the outputs. But it's only going to do it sort of where they all overlap, right? So if we set van CMA and raster T reclass, again, this name might be a little different on your end. Just make sure the Polygon version of the NDVI layer and the census tracks, right? And your output name will be something like this. Provided you put them in this order, Arc's going to auto-generate these output names. And so let's run it and just see what happens. Now there's a lot of records in here, so it does take a moment, right? If we turn this off, just get this band CMA-CT intersected layer, we can see that, okay, well, it just covers the areas covered by this. But if we open the attribute table, we can see that it has not only all of the census stuff, right? But also it's got this, right? The grid code value. And so if we wanted to sort of visualize what it's doing, again, just go to the symbology, unique values, and find this grid code value. And so it's important to note how, again, just X this out, right click, remove. It's important to note how different this looks compared to this one, right? So this is the census boundaries. This is the census boundaries overlapped with the boundaries of the different areas, urban, medium density, residential, or green area, right? So it subdivides, right? This one census block subdivides it into a whole bunch of different ones, right? Any continuous area. And so even though these green areas are continuous here, it subdivides this part because it splits a census, right? And so this is useful because we can take this information here and use it to figure out, okay, well, how much green vegetation area is there per census block, right?